Hi everyone, welcome back to General Chemistry 1. We are now talking about Chapter 3, Stoichiometry calculations. So I'm going to discuss two major types of calculations that involve in stoichiometry. So what is stoichiometry? Stoichiometry can be understood as some type of ratio. So stoichiometry calculations are calculations based on coefficients. Basically, it's mole ratios or mass ratios from a balanced chemical equation. Okay, so you can treat all the coefficients to indicate some type of quantities, either as moles or number of molecules or number of substance, something like that. And the key to solve these stoichiometry calculation is to do the ratio, math of the ratios. So to establish the correct proportion. Okay, let's take a look at a question. So something is a mixture of iron oxide and aluminum powders that and undergoes a reaction to yield sodium aluminum oxide and molten iron. Okay. So how many moles of iron 3 oxide are needed to form 3.6 times 10 to the third mole of iron? Now, from this equation, you know that there is a reaction, and the calculation is based on a chemical reaction. Very likely, it's stoichiometry, calculations. So first, we need to write out the balanced chemical equations. I'm not going to do into the details, but the balanced equation is iron 3 oxide plus aluminum. It can produce aluminum oxide and iron. So this is the chemical equation. What it provides from the question is the number of irons produced. Okay, it's a product. And it asks is the number of iron 3 oxide are needed. So it asks you the relationship between one reactant and one product, and it gives you the information of how many quantity of product is made. So if you think about this way, every molecules of the chemical reaction needs to strictly follow the ratio from this chemical equation. So then if how many product is provided due to the restrictions of this chemical reaction, we can get how many reactants are needed. So now we need to establish a proportion. Here's the most important part, okay? Pay attention. Assume X moles of iron 3 oxide are needed. We ask about it, and we can assume X moles are needed. Then we can establish a proportion, first based from the chemical equation. 1 mole of iron 2O3 leads to 2 moles of iron, as I listed on the left part of proportion. On the right, it's in the real world, okay? Now we can have X moles of iron 3 oxide consumed, and then that leads to a 3.6 times 10 to the third moles of iron made. Okay, you can see the top we also use iron 2O3, the bottom we use iron. So it's corresponding to its left values. From this proportion, on the left, it's information from the chemical equation. On the right, it's information from the question, including something we need to solve and information from the question. Once we establish this proportion, we can do the cross multiply to solve the X. The cross multiply is you cross multiply these 4 items, and the cross multiply result are equal to each other. So 1 times 3.6 times 10 to the third equals to 2 times X. Okay, now you can solve this equation. It's now turning a chemical problem into a math problem. So the x equals to 1.8 times 10 to the third. And the unit is after the x. So we now have, we need 1.8 times 10 to the third moles of iron oxide, iron 3 oxide, to form this amount of iron. Okay, look at this question. Established proportion is a key. Sometimes, besides ask you or providing you information about moles, the quantity, it's providing you information about mass. For example, here, a tarnish that forms on an object made of silver is solid silver sulfide. It can be removed by reacting it with aluminum metal to produce silver metal and solid aluminum sulfide. How many moles of silver are produced when 32.6 grams of silver sulfide reacts? Again, here it mentions a chemical reaction. By tracking the word reacting, the two reactants are silver sulfide and aluminum. The products are, you see here is the word produce. The products are silver metal and aluminum sulfide. And based on this chemical equation, it asks you the relationship between two substances from the chemical equation. So it's a stoichiometry calculation. And first, we need to write out the chemical equation. Here it goes. Silver sulfide reacting with aluminum to produce silver and aluminum sulfide. Okay, now, because coefficient, if we want to establish the proportion from the chemical equation and using the coefficient only refers to quantity. Now it has mass. What are we going to do? We can convert this mass into moles, and then we can do the proportion based on quantities. So let's do that. Convert mass to moles using this equation. Number of moles equals to mass over molar mass. The 32.6 grams refers to silver sulfide. So looking up the periodic table, and we can get the molar mass of silver sulfide is 248 grams per mole. Then we can convert this amount of silver sulfide into number of moles. Okay, plug in numbers, and we can get there are 0.13145 mole of silver. So pay attention here. I try not to run off in the intermediate steps, and if we need to, I keep a lot of 5, 4, 5, 6 digits after decimal if possible. Okay, now we know how many moles of silver sulfide are there. And we're turning this question to the previous one. Now we need to establish a proportion to solve how many moles of silver are needed. So again, assume X moles of silver are needed. From the chemical equation, we can get the relationship between silver sulfide and silver. 3 mole of silver sulfide, the 3 is from coefficient, needs 6 mole of silver, right? So these are the relationships from the chemical reaction. And that equals to 0.13145 moles of silver sulfide we get from the question, and we calculate from the question, and then X moles of silver needed. Again, pay attention to this proportion. All the units are the same. And also, the top refers to silver sulfide and the bottom refers to silver. The left is from chemical equation, the right is from the question. You can now cross multiply to solve X. 3 times X equals to 0.13145 times 6. Then the X equals to 0.263. For the final answer, we can run off to match the significant figures of what is provided in the question. So we need 0.263 mole of silver to produce 32.6 grams of silver sulfide. So this is a type of question of stoichiometry calculation involving mass. As you can see, convert the mass to moles, and then we use the previous method to solve the number of moles of the, what is asked in the question. Again, establish this proportion is a key. All the others are preparations. So if you establish this correct proportion and do the math correct, you get 90% of stoichiometry calculations correct. All right, this is the end of this video. I'll see you next time. Bye.